Hi all, this is the MakeHaven training video for our Prusa 3D printers. The Prusa 3D printers here are the ones that we use most frequently because the filament that they use is inexpensive and it prints quickly. The reason that we have all of these Prusa, which is just the brand, is for just consistency so that it's easier for you to learn one system and then be able to use all printers of these three different sizes. So here we have these minis, which as you can tell are the smallest, and then these are sort of their normal size, and then over here we have the XL printer, which has an enormous build volume, and so that is great. It also has two print heads, so you can print in two colors, which is a pretty cool feature. You could also print with dissolvable supports, which is something we'll cover later. So this is sort of a brief overview of the printers themselves. Then we're going to go look at how to do all the stuff on the computer before we come back here for the actual printing. What I'm going to cover here is just the basics of how the machine works, so when we're at the computer you know what we're talking about. So these machines take this filament of PLA plastic, polylactic acid, and they heat it up in this heater down here and squirt it out of a nozzle at the bottom right there. And they do that in a controlled way by moving sideways and forwards and up and down to print out all sorts of cool shapes. The only other useful piece of information that we're going to get here before going over to the computers is that each printer has a name. So here, this one's called octopi2.makehaven.org. So that's the website you can go to connect to this printer when you're on the MakeHaven Wi-Fi. So now we're going to come over to the computer. Please show you some different ways that you can make the 3D printer files to 3D print on the computer. I'm not going to go too deep into this. There are plenty of other videos out there, and you're welcome to ask facilitators for help on more advanced techniques on how to make the files, but here are some basic ways. So one is you can go to many online websites. Maybe the most famous is thingiverse.com, where you can find thousands and thousands of files that other people have made that you can just search through and download to see, if conveniently something does what you want it to do. So box making corner jigs, owls, vases, a recipe book stand. There's many, many thousands of things out here that people have made. You can also make your own things and upload them. So let's say we wanted a soft tape measure spool. You could click on it and then you can download the file. So when you click on download all files, then it will download what's called an STL file. So here you can see the zip file. We open it up, and inside of it are the files. So here are the STL files, and STL stands for stereolithography, but pretty much STL file types are the mesh that describes the 3D shape that you want. So you can't send this file directly to a printer. A printer won't know what to do with this file, but you can open this file up in other programs and you can see the 3D rendering of what that mesh looks like. So now I'm going to show you two other ways to get to STLs, and then we're going to see what we do with those. So another way would be to go to a website like Tinkercad. So Tinkercad is a really basic CAD program, computer assisted design, and it lets you use simple shapes to make different designs. You can do more complicated stuff with it, but it really isn't meant for very complicated things. But here you can see I needed an adapter for a belt grinder, and so that was really easy. You take a circle, you add a negative cylinder within it, and then it makes this adapter. So sometimes it's a great tool for making really simple shapes. Then you would export it and download the STL file. Then here, this is sort of cluing us into our next step. It says take your designs further with Autodesk Fusion. So over here, this is a program called Autodesk Fusion 360. It's mostly free. You can have up to 10 editable files at a time for free. There's also other free programs like Onshape, which is web-based. So here's a design that I made. This is a planter that goes on the wall, just a little sort of cup planter. And this shape would be very hard, maybe impossible to make with Tinkercad. But in Fusion 360, it's relatively easy. So these are different ways, and then from Fusion 360, you can select this body and right click and then save as a mesh, and that's how you get the STL from Fusion 360. And again, with Fusion and for Tinkercad, there's tons of videos out there, tutorials, and other member and facilitator expertise that you can lean on to learn more about how to design these files. So then once you have your STL, and we'll just use that tape measure spool thing, then you want to go to a program called Prusa Slicer. Prusa Slicer is something you can download for free on the internet. You just Google Prusa Slicer, download it for your computer and install it. A slicer is a tool that takes an STL, which is that three-dimensional mesh design, and it slices it into layers, and each of those layers is a layer that the 3D printer can print. And that'll make a little more sense in a second once we see something that we've sliced. So here we've opened our Prusa Slicer, and we need to make sure that it's updated to the most recent version for all the features to work. The first step is to select the printer that we want to use. So here you can see you could select the Mini, you could select the original, which is sort of the medium size, or you can select XL. On yours, if you've just downloaded Prusa Slicer, you'll need to click Add or Remove Printers, and then add a preset, and you can click through all of the 3D printers that Prusa has, or others if you want to use the slicer for other 3D printers. So for here, for the Mini family, I've selected the 0.4mm nozzle because that's the standard. So input shaping is a technique that lets some of the prints print faster. So that's what I downloaded. So here we have the original Prusa Mini input shaper, selected that. Then we go down to the MK3S and MK3S Plus, selected that one. That one does not have input shaping. And down here we go to the XL multi-tool family, and we have the Prusa XL with 2-tool input shaper, except we have the 0.6mm nozzle. So make sure to select that preset. I'm going to start with doing just the Mini so you can see what that would look like. And I'm going to discard all of those presets. So here's what the Mini looks like with its bed. I'm going to click up here to import our STLs. Here we are. I just clicked into the tape measure folder, files. Here are these 3 files. For now, I'm just going to print the bottom and the outer piece on the Mini, so we'll demonstrate that process. When it loaded them, it stacked them on top of each other, so we can just drag them apart like that. The manipulation of the screen probably depends a little bit on your computer, but in general you click and drag to change your perspective by rotating, and then you can zoom in and out like this. You can also pan and do all the other things, but in general those 2 are enough. I'm going to run you through some of the most basic features in Prusa Slicer, but the slicer is very feature rich, so you can keep digging deeper into all the capabilities that it has to offer. So just going through the main ones we see here, this is obviously moving, this is scaling if we wanted to change the size of our parts. This will rotate, then this lays flat, so maybe I'll go a little deeper into these features. So a 3D printer is like a hot glue gun that's squirting out plastic. And if it squirts out plastic in midair, that's just going to fall right onto the print bed. It's not going to stay suspended in midair. So let's say we rotated this piece here like this, then what would happen when the 3D printer is printing up here is it's just going to fall straight down. So we would need to put supports underneath that if we wanted to support it so that it doesn't fall straight down. And in some prints, that's inevitable. There's no orientation where you can avoid that. However, in this case, we can avoid it because if we print it on this surface, then the only piece that needs supports is this little piece right here. And that just minimizes the amount of supports we have to print, which is great because the supports get thrown away anyway. So if we can minimize that, we save time and plastic. So the lay flat tool lets us select a face, and then it drops it right down onto the print bed on that face. Now the printer can handle some amount of overhang. So let's say it was oriented something like this, then it might be able to print this angle because each layer is a little bit supported by the one before it. But at some point when it's totally over, then it's not going to be able to handle that and you'll need supports. And that degree, that angle is something that you can change in the settings. We're going to lay it back flat normally. And then here you can cut the pieces. So if you want to modify your files within Prusa Slicer, you can do that. One of the cool things about Prusa Slicer is it allows you to do more modifications than many other slicers. So if you want to add shapes, take them away, modify them, you can do that. By right-clicking on a part, it lets you do a whole bunch of things, including adding modifiers of different shapes. Then down here is painting on supports. So let's say you just want supports on a particular area of your piece. You can paint them on. Seam painting is a kind of specialized tool that is more for the aesthetics of the part. So we need to get into that, and then you can measure. Then up top here, you can add parts, remove them, delete them, duplicate and arrange. You can add more instances of them. Here you can have variable layer height. Some parts you want to have thicker layers, and some parts you want thinner layers. Over here on the Mini, it lets you specify a few things. One, how thick do you want your layers to be? The thinner the layers, then the smoother your part will be, but the longer it'll take. The thicker the layers, the faster it'll take, but maybe a little less aesthetically attractive. Another thing to bear in mind when you're printing is that the adhesion between each layer is generally not as strong as the strength within a layer. So if on this pin we're really worried about that pin snapping off, then we could alternatively print it like this. So then the layers go along the pin and integrate it into the base. And then it'll be that pin will hold onto the base a little more strongly than if it's oriented vertically. In terms of the filament, we use only PLA on these printers, so you can just leave it with generic PLA. In terms of the supports, that determines whether it will print with supports or not. It'll give you a warning when you slice it if it thinks it needs supports and you haven't added them already. Since we know we're going to need at least a little bit of supports underneath there, what we can do is click supports everywhere, and then it'll figure out, based on the angle that we determine in the settings of where supports are needed, where to put them. Infill is an important setting that determines how much of a shape is filled with plastic. So if you wanted it to be the maximum amount of plastic, you could set it to 100. In general, 15 is a pretty good number. And then brim helps the part adhere to your base. Down here, you can control more numerically the position and the size of your pieces. And then if you want to get into more advanced settings, what you can do is click through here. So up on print settings, that lets you do a whole bunch of different things. So you can have all sorts of details about your support material. For example, the overhang threshold that I was talking about is set to 40 degrees. The colors here indicate how advanced they think that setting is for the users. So green is simple, yellow is advanced, and red is expert. In general, the default settings are pretty good, so I would err on the side of not editing these settings unless you print and it doesn't go well, and then you have a reason to change them for a specific reason. One setting you can consider changing is the style of supports if your print requires supports. So here we can change it to organic, and that activates some organic supports options down here. But I'll show you what that looks like with all the default settings. So here we go to the plater. We'll take you, and just for the purposes of demonstration, tilt you up like this so it needs a lot more supports. Then we'll slice, and instead of making conventional rectilinear supports, it makes these really cool looking supports. These touch on many fewer points on the surface so that it's easier to break off and it uses less material. And you can see kind of why they are called organic. So that's a good option to know about. A commonly changed setting is the infill pattern. So here the default is grid, but you can also set it to gyroid as a popular one, but there's all sorts of different infill patterns that could be appealing for different reasons. Then we have some filament settings. In general, those aren't terribly relevant. Here under printer settings, there are also not too many things that you should need to mess with. So here we are back at the plater. Now what we're going to do is we're going to click Slice Now. And we can see what it has done here. So it's color-coded the different kinds of materials, the perimeter, all the different things. If we look underneath here, you can see the green is the support material. It tells you what percent of your print is made of each kind of action, whether it's a perimeter or an infill, etc. And it also tells you how long the print will take. Here it's about 31 minutes. If you want to look through the layers, then you can drag down here. That makes it sort of evident why it's called a slicer, because it's cutting up into these slices. So that's useful, and we'll get a little more into that when we look at the XL printing functionalities. And now what we're going to do is we're going to send this sliced file to a 3D printer. So I'm going to click Export G-code, and it's going to save to our downloads, save, binary is fine. Okay, so we've exported that. And now we're going to go over to one of the Prusa minis to get it ready for printing. This one doesn't have any filament loaded into it, so maybe this is a good example. I'm going to get some filament. You're always welcome to bring your own PLA, or you can purchase a standard or mini spool in the store. Remember to pay for those spools before you leave, either by scanning the QR code on the shelf, completing an envelope and putting cash in the cash box, or going to MakeHaven.org/store to search for the item and click Add to Cart to complete the payment on the site. Notice that the end of the filament is through the hole in the side. It's important that it stays there when it is not being used so that the filament doesn't get a twist in it, because then it'll bind up when it's printing and cause the print to fail. And I'm going to load this filament onto that spool holder back there. Here I've put the filament on the rollers so that it can unspool itself, and you can see that the tip has a little bit of a mushroom to it, and we want it to feed really nicely into the printer. So we're going to use these snips that are here to snip off the tip, and we're going to throw it out so as not to make a mess on our nice table. And you can see that I snipped it at a bit of an angle so that it feeds more nicely into the printer. Now I'm going to go over to filament right there, and I'm just clicking here to select, then load filament, select PLA, and then here it says press continue and push filament into the extruder. So I'm going to push continue and then push this right into here so we can see the filament getting drawn into it, and then it's coming down into the print head. So we can see it purging the orange filament that was in there, and it's asking, is the color correct? And no, it's coming out orange, not that gray color yet. Click more. And there we go. Now it's doing the right color. It's purging a whole lot. All right, so now we can click yes. As a note, the printers all know when they run out of filament, so if it does, then it'll stop and let you unload the last little bit and load a new roll of filament to continue your print with. I'm just going to throw this out. Now, in terms of the bed, we want the bed to be nice and clean. So here's some isopropyl alcohol for the 3D printing station. Here's a piece of paper towel. And now the bed is nice and clean. If you are having problems with print adhesion, then you can also use a glue stick, but in general, that isn't necessary. So now that this printer is ready, we're going to go over to octopi7.makehaven.org on the computer and send the file to this printer. Now we're going to go over to octopi7.makehaven.org. Occasionally, it will ask you for a username and password to get to this page. If it does, you just enter MakeHaven for the username and MakeHaven for the password. Also, sometimes the printer might be offline. If it were, it would just look like this. So then you would just click connect, and it will automatically connect to the Raspberry Pi if it is online. So now this says operational. And we are going to upload our G-code file The G code is what we exported from Prusa Slicer, and that is the file that the 3D printer can read. Octopi is just sending that file to the 3D printer and showing us some data about it. You can make your own folder here if you want to do a lot of printing and you want to keep all your things in a folder. Keep in mind that we have limited space on this card, so it gets purged, so you don't want to try to keep anything here long term. So I'm going to upload the G code file that we made. And here it is. So by clicking load, this little folder button, you can get it to pop up here. You could also just click print and it would immediately start printing. So here you can see the filament that it's going to use, which is 3.8 meters. You can also, Prusa Slicer, you can see this. If you go to the 3D editor view and select your parts, you can deselect inches. And now when you go to look at the sliced info down here, it'll tell you how much filament it uses in meters. So it can tell you this in the slicer as well before you get all the way to Octopi. So here we are back at the Octoprint, and we have this file, and you just click print to get it started. You can also click pause and cancel to pause and cancel the print. Here it will show you the temperature of the extruder and the heat bed. And you can also do some controlling from here, but in general it's better to do that from the printer itself so that it's easier to restart. But if, for example, you pause the print at the printer, then you can resume the print from here, so that the two do talk to each other pretty well. So here you can see that the printer is doing its automatic bed leveling, so it's going around and measuring the bed, and it's still at 173 degrees, and it's going to heat up to 215 so that it'll be ready to print. So now it's printing that first line, and that first line looks pretty good. What we're looking for is a line that is smushed into the bed. Not if it's too low, then what it'll do is it'll look like there's nothing there, and if it's too high, it'll look like a bead of plastic that's sitting on the top. If it doesn't look good, what you do is you go to Tune and then Live Adjust Z. So I'll show you what that would look like. So here, when we turn the knob, it raises it up and down a little bit. So I'm gonna bring it too high, so we'll see what that looks like. So now you can see that here, that just looks like a bead of plastic sitting on the surface. That's not being smushed into the print bed at all. So we want to bring that back down to where it was. And now I'll go too low. I'll show you what that looks like. I'm just going to put it back to a good print setting. All right, so here you can see that that layer is almost see-through. So it was squishing the plastic down so hard that there was almost no plastic coming out. And what we want is just in the middle. We don't want a bead sitting up, and we don't want nothing coming out. So that's what we set it to. And it's important when you're printing the first layer of your print to watch it and to make sure that the first layer is good. If the first layer is coming out well, like this, where it looks like a nice first layer, then chances are your print will come out well. But if you just click print and then walk away, chances are the problems in your print are going to happen in the first layer, and you're going to miss that, and then the whole thing is going to get messed up from there out. So we're just going to watch this first layer and make sure that it comes out hunky-dory. So now that the first layer was printed successfully, we feel pretty good about this print. I'm just going to show you some of the other options here. So you can click Tune, and in addition to Live Adjust Z, we could change the filament, cancel, change some of the print parameters. In general, you don't need to change any of these things. And then you could obviously pause and stop the prints. So now we'll let it print, and we're going to go check out the print for the XL. So we're going to come over here, and this already has filaments loaded. It's pretty much the same setup in that you take the filaments and pass them right into number 1 and 2 down there to load them into the machine. And you over here filament, and then we could load a filament, and it's pretty much the same setup. When you're done with your print, then you can unload the filament, which heats up the extruder and then reverses it out of the machine. If you have personal filament, you can keep it in a personal storage area in a Ziploc bag to keep it dry. If you come upon a print that's finished, then it's considered just to unload that so that the person can come pick up their filament and the part, which you're welcome to remove and put on the finished print shelf over here. Then you can put a label on the print bed that will go with your print, with your name and the date, so that people know it's yours. Now we'll go back to the computer to get our files set up and send them to the Prusa XL for printing. So the website for this printer is octopi10.makehaven.org. So we're going to go get the print started at the computer. So here we are back at the Prusa Slicer. We're going to delete these parts so that we can print the other part on the Prusa XL. We can discard all of those settings because we're just going to start fresh, and we're going to import the core piece, which is this piece. All right, now as you probably noticed, this thing popped up. This is a wipe tower. The purpose of the wipe tower is to make sure that the extruder, each time it comes out to be used in that print, is primed and ready, because when it's sitting in the dock at the back, it cools down and the filament isn't just up to the tip of the extruder. So if you're experiencing under extrusion each time a new extruder is used, then adding a wipe tower might be helpful. This could especially be helpful if you're using soluble supports. In my experience, this hasn't been necessary. I've gotten great results without using the wipe tower. But if you are experiencing problems, that could help address your issues. So what we can do is go to Print Settings, click on Multiple Extruders, Wipe Tower, and we can just unenable it. We go back here, and that is gone. Now here, I'm just going to look at the differences between the XL and for the Mini and normal size Prusas. So first off, because this has the input shaping, which the Mini can also have, here it refers to speed versus structural. So we can do more input shaping, which means printing faster, or it can focus more on the structure and dimensional accuracy of the print. And then we also see the same layer height option that we have, going from a thin lower height up to a thicker layer height. One of the benefits of having multiple extruders is that you can use soluble supports. So here are two options for those supports. Soluble full would mean that all the supports are soluble. Soluble interface just means that the connection between the supports and the part that you want to print is soluble. We don't currently have soluble supports available for use and purchase, but you're welcome to get them yourself. Here on the Prusa website is the verbatim BVOH soluble support that works with PLA. So you're welcome to get this or something like this, as long as it's water soluble to use for your prints. It may also be helpful to refer to some of the documentation on the Prusa website to get the best results. Prusa has a ton of amazing documentation. The slicer here doesn't know or control what colors of filament you put into the machine, but what you can do is, and so really this is just saying extruder 1 and extruder 2, but you could change the colors to make them represent what's actually in the machine. I believe extruder 1 is white right now and extruder 2 is black. There are two ways of changing the colors on the piece. The first way is using this painting tool, so multi-material painting. Use the left mouse button to apply the first color, the right mouse button to apply the second color. Here we have first color being 1 and second color being 2. You can use a brush, which acts like this. Or you could do Smart Fill, which will try to fill the surface that you're clicking on, and then the Bucket Fill, which will try to color everything that currently has the same color. And then you can change, if we're using the brush, you can change the size and the shape of the brush. I'm just going to clear that brush mark that I did and show you the other way. So the other way of adding different colors to your print is by slicing and then going here and here. As we saw before, you can go and see what the print looks like on the inside. But what we can do is assign different colors at different heights. So if we bring this down here and right click that plus icon, we can click Change Extruder,
extruder 1 is already active, so we can't change to that, but we can switch to extruder 2. And now this changed to the extruder 2 color. And then we'll go up, and we'll make the knob back to extruder 1. There we go. And we can click slice now. So right now it's color coding this based on the feature type, but we can change that color coding setting to the color of the print, and now it renders it with reference to the colors that each extruder has been assigned to. As a note, at this point I don't believe you can do the painting tool and this way of assigning colors at the same time. So you have to pick one or the other. There are probably also a bunch of other ways of painting your print in different colors by using the modifiers. So in this setting, by right-clicking, you can use all these modifiers, and using those you can probably assign different colors to them. But in general, those are two ways of changing the color. Another is if you had multiple parts, then you can right-click here and change the extruder assign for the whole part. But if you're doing that, then it probably makes more sense to just print them separately. Because let's say we have two parts here, and we have one color and one the other, it has to change between extruders for every layer. So that's going to slow your print down a ton. So it probably makes more sense to just print those separately. Now another note is that this printer is really large. So you could make a pretty enormous print on this. And it doesn't quite capture the scale, but this part here is about 7 inches in every dimension. So we can see how long that would take to print, and that would take about 14 hours to print. So to be mindful of how much time you're using the machine for, if you are doing a large print, try to make sure that your print is optimized in terms of speed, so choosing thicker layer heights, as well as reducing the infill so that it isn't spending more time than needed printing on the inside of your part. So I'm going to go back here and change our part to how it was, re-slice that, and export this. And this is the core, so we'll save that to downloads. Okay, then we're going to go over to Octopi 10, and it wants us to log in, MakeHaven, and it looks like there's currently a printing on the machine, but when it's done, what I'll do is, same as what we did for the other file on the Mini, is upload it, and then when the other person's print is done, I will start this print on it so we can see how that goes.
So now that the print is finished on the Mini here, we can see what it looks like. The prints look great. To remove the prints, this steel print bed just pops off, and then now that it's cooled, it should pop off really easily. So what I'm doing is I'm just bending the plate a little bit, and you can hear the parts popping off. Now they should be pretty easy to remove. There's some supports underneath here that you may recall us putting in, and this little guy popped off as well. And then for the next person, we just want to be considerate and remove these bits. So they should peel up, and we can just toss those. And then we're just going to put you right back like that. So supports can sometimes be a little bit annoying to remove, but here I'm just using a knife to pop out the supports here. And here it is with the supports removed. And then we can take this piece and put it in here. There's a really satisfying click right into that hole. So now the printer's going through its bed leveling program, where it goes around and takes a whole bunch of measurements all around the bed. And when it does this, it can leave these little dots on the surface of plastic. And let's say you were to cancel your print after it does this and before it does the print, then it'd be important to clean these little dots off so that when it does the next calibration, those dots don't mess it up. So you would just want to wipe some of those little dots of plastic off. Similar to the other printers, you can clean the bed just by wiping it with paper towel and isopropyl alcohol. So here it is doing its first layer. On the XL, it's so confident in its ability to get the distance between the extruder and the print bed right that there is no live Z-adjust or first layer calibration built into it. So it's still important to watch the first layer to make sure it's getting good adhesion. Maybe you need to clean the bed more, use a glue stick, but the distance between the tip of the nozzle and the print bed should be good all on its own. And here's the final print. So we might just be able to pop that off nicely. If not, you can remove this bed just like you could remove the other ones. And now here we have our not terribly useful measuring tape winding tool all printed out. If a print did not go as planned, then we have these red X marks. So they have magnets on them and you can stick them on a frame so that one of the facilitators or staff knows that the tool needs to get worked on. You can also post that on the MakeHaven Slack channel for 3D printers so that other people know that it needs some maintenance. And then last but not least, as with all the areas here, make sure to clean up when you're done. So you want to make sure to pick up any stray bits of filament to make sure that you're leaving the place cleaner than you found it. So I hope that was helpful, and have fun 3D printing.